Hi guys, and welcome to this further maths video on problems involving simultaneous equations. Yes, it's building on the previous videos we've recorded for this course, which can be found on mathsguru.com. Yes, I am Darren, otherwise known as Maths Guru, and it's really good to see you. Yes, mathsguru.com is where you can find all of these videos where there are downloadable notes, there are exam style questions from VCAR. The videos are all sort of organized by textbook, and there's so much more to come. So head over there, it's free to sign up. And if you can do me the honor of subscribing on YouTube, we'll be deeply grateful as well. Why? Because I'm never going to be rich, and I'm certainly never going to be famous. Who watches videos on YouTube? Well, lots of people, but not maths videos. Yeah, just subscribing lets me know that you are out there. This learning objective is to apply the knowledge of how to solve simultaneous equations using the following methods. Now, substitution, elimination, and CAS. This is actually a CAS course, so on the whole, we're going to use a CAS for these particular examples. Yes, but it's nice to know that there is a video out there, previous videos, in fact, showing you how to do substitution and elimination. Now, in our previous videos, if you haven't watched it, you can watch it on Maths Guru, watch it on YouTube. We looked at the idea of how to use the CAS to solve simultaneous equations. And we came up with the idea that effectively simultaneous equations were nothing more than straight line graphs that crossed in a certain point. And generally speaking, where they cross is a solution to something we're looking for. Now, in previous years, in year 10 or what have you, we just made you do it for the sake of doing it. You did it by pencil and paper, you did it in all sorts of different ways. But in further maths, you've used matrices to solve them, CAS, linear equations, blah, 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 blah. And as I said in a previous video, we could either solve it graphically, which is what's happened here. We put the two equations that we had in, and we had a graph. We looked at the intersection point, and we found out where the graph intersected. Or we put the two equations into our sort of linear equation solver, and again, out come the value. And interpreting what that value means is incredibly important. Please don't underestimate the importance there of the values of what's coming out. So, as it's a CAS course, I said here we're going to use the CAS, all right? Yes, you can do pencil and paper method if you want to, and maybe stretch yourself. For those of you out there who want the 50s and the highest exam scores, have a go at doing this by pencil and paper as well. But I'm going to use the Casio ClassPad, which is my calculator of choice at the moment. Used to love the TI Inspire, but the Casio, I think for many of the things that I do, is much simpler. So let's break an example down into stages. And these examples are taken from the Cambridge Further Maths textbook. And thank you very much to Cambridge for allowing me to use your examples. Gratefully appreciated. There are two possible methods for paying gas bills, method A and method B. Now, the thing I'm looking at here is they've given me two methods, which ultimately means there's going to be two equations I can get out of this stuff. Determine the number of units that must be used before method B becomes cheaper than method A. This is screaming at me, draw a graph, find the equations, and work out which graph is cheaper or better at particular points. So method A fixed charge of $25 per quarter. If you remember from a previous video, fixed charge is really just my intercept, plus 50 cents per unit gas used. Okay, that sounds like a gradient to me. Method B, a fixed charge of $50 per quarter, ouch, plus 25 cents per unit of gas used. So that's got an initial or a higher initial charge, but less for the gas. The other one has a lower initial charge, more for the gas, and this is how they sting you every single time. All right, so let's look at creating equation 1 from method A. So we know the cost of my gas, and let's call it cost, and let's call it cost 1, is equal to, and we know that a fixed charge is a payment that I'm just going to have to pay, which is $25 plus 50 cents. Now, again, notice the difference here in units. One's in dollars, one's in cents. So we have to put 0.5 and times, let's call it, I don't know, let's call it X, where we're going to define X to be the units of gas, all right? So that's per unit of gas. Right, awesome. C1 equals 25 plus 0.5. So let's write that slightly nicer. C1 is equal to 25 plus 0.5x. Thank you very much. Now, the units of gas for method A and method B are going to be the same. So actually, I can use the same variable in my next equation to stand for gas, but not my cost. Now, don't press stop, not just yet, guys. This is a preview video, and you've reached almost the end of it, but it does continue over on mathsguru.com. Mathsguru.com, yep, that's my custom website. Bits of it you can see around me at the moment. That has been designed to allow the videos to be easier searched than they are on YouTube. So you can search by chapter, by textbook. Each video has downloadable notes for you, so you can put them in your summary book or your exercise book. There are exam questions, and there is more and more content and more stuff coming. as time allows. So head on over there. It's absolutely free to sign up, and I'm doing everything I can to make sure that you guys enjoy maths and actually take out the mastery of maths. It is not as hard as you think. It is all smoke and mirrors. Okay, thanks very much. Take care, guys. I look forward to seeing you in another video. Stay safe.